Hi, this video is meant for IGCSE 0606 or O Level Additional Mathematics. In today's video, you'll be learning what makes a graph a function, why might a function not have an inverse, how to find expressions for functions, and how to sketch an inverse graph of a function. Now, this video is the second part video to my first video on the topic of functions. In my previous video, I have already covered how to find the domain and range of a function, how to find an inverse of a function, and how to solve for composite functions. This video will follow the 0606 Cambridge IGCSE syllabus, and we will be learning how to apply these concepts by solving past year questions. So let's begin. Now, this is the first question I'd like to look at. Diagrams A to D show 4 different graphs. In each case, the whole graph is shown and the scales on the two axes are the same. So we have 4 graphs here, A, B, C, and D, and we have been given a table. Place ticks in the boxes in the table to indicate which descriptions, if any, apply to each graph. There may be more than one tick in any row or column of the table. So we have 4 criteria here. Not a function, one-to-one function, a function that is its own inverse, and a function with no inverse. So let's look back up here. So we have 4 graphs here. Now, the first thing we should know and have to understand is what type of graphs actually are functions. So we have many-to-many, many-to-one, one-to-many, and one-to-one graphs. Now, these are considered graphs, but not all of them can be considered as functions. Well, so what exactly defines a function, right? First, we must understand what these names really do mean about the function. So the first word here, usually at the front, the 1 in one-to-many stands for the x value, and the word at the back, in this case many, stands for the y value. So from one to many, we can understand that one x value corresponds to many y values. For example, if this value of x is considered as 2, we will get back 2 y values. So let's say this could be a 4, and this could be a negative 4. This is the example of a one-to-many function. Now, let's do this on the one-to-one example. So for this graph, the one-to-one graph, for each x value, there is a corresponding y value, right? Same thing here. There is a corresponding y value. So this could be defined as a one-to-one function because for every one x input, it corresponds to a single y input. What you must know is that only 2 of these 4 graphs are actually considered as functions. A many-to-one function and a one-to-one function, a one-to-one graph are considered as functions. The other 2, like a many-to-many graph or a one-to-many graph, are not considered as functions. Knowing this, now we can move on to solving this question, right? So first of all, we need to identify which of these graphs are actually functions, because our first criteria here states that to tick which graphs are not functions. Okay, so let's identify them now. So A. So let's test out what type of graph this is, right? So let's say I have let's say I draw a line here, and let's say this is y is equal to 3. Doesn't matter. But at y is equal to 3, if we move down, we can actually see there could be 2 different values of x. So many values of x to 1 value of y. So this graph is a many-to-one function, because as we know, many-to-one graphs are considered as functions. Now let's move on to B. In B, let's say we have it's pretty obvious that let's say we have a singular x value here of 1, and you can actually see that this x value of 1 can give us 2 y values. So 1 to many, and as such, a one-to-many graph is not considered a function. So this is not a function. Okay, now let's move on to C and D. Alright, this may look a bit funny, but let's try it out. So let's say I have my x value here, go down. Oh, and this line of the x value only cuts a single point on the single point. And let's say I have another point here. So for each x value, I will also get back a singular y value. So this function is considered as a one-to-one function, or one-to-one graph, and that makes it a function. Yeah, this is pretty similar for D. I'm sure it's easy to catch on by now, but D is also a one-to-one function because for every x value there is only one corresponding y value, for example. So this is also one-to-one. Alright, now we know this. Okay, so not a function. Which ones are not functions? Well, B is the only one we've classified to be not a function, so let's just take this. Which ones are one-to-one functions? We've identified C and D to be one-to-one functions, so we just take them here. Now, our next criteria states that a function that is its own inverse. What exactly does the question mean by this? Well, in order for a function to have its own inverse, it needs to be a one-to-one function. And if you look up, we only have two one-to-one functions, C and D. So the only two functions which can qualify for this criteria are C and D, right? So now let's reflect the graphs of C and D on the line y is equal to x, because inverse functions are functions which are reflected on the line or the graph y is equal to x. So let's draw our line. Y is equal to x. And let's say I were to map it like this to draw a inverse function. And yes, it is the same. So we do know that C actually qualifies for this criteria, right? However, we still have to check D for this criteria. If you're still confused about how to draw an inverse function, I will cover that later. So please feel free to stick around and see how I do that later. Alright, one-to-one function here. So now let's draw the line y is equal to x again. Y is equal to x. Okay, so now let's say we take this point marked x and we reflect it across the line y is equal to x. And let's say we take another point. Let's say we take this point. And the line actually ends up here. So your inverse graph may actually end up looking something like this. Let me draw this. Oh, my bad. Your inverse graph may actually end up looking something like this. Yeah. However, if we were to draw the inverse graph for this, for the graph of C, you'd actually realize that we actually get back the exact same graph. So in this case, only C can qualify for this criteria, and it's the only one we should take for a function that is its own inverse. Now, our fourth criteria states that a function with no inverse. So which function has no inverse? Well, first of all, it cannot be B because B is just not a function, and the question is asking us for functions, right? And only one-to-one functions can have an inverse function, so we know that since A is not a one-to-one function, it is not able to have an inverse. So answer is just simply A. This is your final answer. Alright, moving on to our next question. The diagram shows the graph of a cubic curve y is equal to fx. So if we scroll down here, we can see that this is our graph. It's a cubic graph and intercepts, and this graph intercepts the x-axis at -2, -1, and 5. It also has a y-intercept of 5. So we have to find an expression for fx over here. How can we do this? Well, we know that the roots of a graph come from its expression. So what can we do with this? Our x-intercepts are x is equal to -2, -1, and 5. So a cubic graph is x multiplied by itself 3 times, right, to get x to the third power, or x cubed. So we need to have a minimum of 3 brackets. And since we know the roots, we can actually just convert them like this: x plus 2, x plus 1, and x minus 5. Now you may be asking, well, why are we turning the negatives into positives, right? Because when we want to solve for roots, this is actually how we get the value of the roots from the brackets. So we actually make, let's take x minus 5 for example. We actually take out these brackets and equate them to 0, because we equate them to 0 because that is the x-intercepts, right, when y is equal to 0. So in order to put an intercept or root of 5 in the bracket form, we have to write it as x minus 5. So basically we just flip the negatives into positives, and we flip the positives into negatives. Okay, but we're not done there, because we also have an expression of we must make sure that our y-intercept actually adds up to 5. And what exactly is the y-intercept of a cubic graph? So we know that cubic graphs are in this form: x cubed plus x squared plus x plus d, or ax cubed bx squared plus cx plus d. Now in order to get our y-intercept, our x must be equal to 0. And when our x value is equal to 0, 0 times anything will always be 0. So the value which will give us our y-intercept is actually d in this case. Alright, so what can we do with this information, right? So knowing this, first of all, let's let everything in our existing graph equal to 0. So just 0 plus 2, 0 plus 1, and 0 minus 5. Okay, so when we do the arithmetic, what can we get from this? We get 2 times 1 times negative 5, and we end up with negative 10. However, we do actually want the y-intercept of 5. So obviously negative 10 times something must give us 5, and if that's the case, our answer should be negative half, right? Because this value needs to multiply with something at the front in order to give us back our y-intercept of 5. Okay, so now that we know that our x is negative half, what we can do is rewrite it like this. So our final expansion for fx is just fx is equal to negative half x plus 2, x plus 1, and x minus 5. That's it. Alright, moving on to our next part. Solve fx is smaller than or equal to 0. So this basically means below the x-axis, right? So when is our graph smaller than 0? Or fx stands for y. So when is our graph, below the value of y is equal to 0, which basically means below the x-axis, right? So we can see here that very clearly in our shaded regions here, when it goes more than 5, or it's in between negative 1 and negative 2. And how can we write this? So it's pretty simple. So when the values of x are in between negative 1 and negative 2, the value of y is actually actually less than 0. So all we have to do is write x, negative 2, negative 1, and this is actually our first answer. We've done the left side. Now we just have to account for the right side. So when x is larger than 5, larger than or equal to 5, and these are your two answers. Alright, now this is our next question. So this question has given us two functions, fx and gx, for all real numbers. So xer is basically just means all real numbers of x. Now write down the range of f and the range of g. Now let's start with f. From our previous video, we've done a similar type of question, and this is just simply f must be larger oh, my apologies, fx must be larger than 1. And now the range of g, well, this isn't an exponential function, and x can really be anything, so well, this is pretty straightforward, just GER, so all real numbers, and that's it. Alright, so our second question here, evaluate fg squared when 0 is inputted as the x value inside. So how can we do this? First of all, let's evaluate g squared or g2 first, right? So this basically means g inside of g of x, this function. Okay, so gx is just equal to x plus 1, and if we put x plus 1 into x plus 1, so what do I mean by this? Okay, let me scroll down. Gx x plus 1, oh, plus 1, and then when 0 is inputted as the x value, just 0 plus 1 plus 1, so is equal to 2. This is just equal to 2, right? Okay, so now let's move on. So now that we do know g squared is 0 equals to 2, we can just input the value of 2 into fx. So let's copy down fx here. So fx is equal to 3e powered 2x plus a 1, and then let's input 2 as the x value, so the function of 2. Now they've asked us to evaluate this, so let's input this into our calculator. And putting this into our calculator, we are able to get the value of 164.79. We can just round this up to 164.8, and that's your final answer. Okay, our next question asks us to sketch the graph of y is equal to fx and y is equal to f to the power of negative 1x, or the inverse of y is equal to fx, stating the coordinates of the points where the graph meet the coordinate axis. Okay, so what is our equation for fx? Fx is equal to 3e powered 2x plus 1. So let's rewrite that. Fx is equal to 3e to the power of 2x plus 1. Okay, and to find our y-intercept, if there's any, the y-intercept always occurs when the value of x is equal to 0. So the function of 0 will be 3e to 0 plus 1. E to the power of 0 is 1. 3 times 1 is 3. 3 plus 1 is just 4. So we know that our graph intercepts at the value y is equal to 4. Now, since this is a double positive graph, meaning that 3e being powered to the 2x and everything's positive, so this will be in the first and second quadrant. We know there is no x-intercept for this graph as well, because of the plus 1 to the back here. This asymptote, this is the asymptote, and it will always be positive, right? So let's draw our graph. Should look something like this. Okay. Make sure your curve looks like a straight curve and there's no wobbly lines. My apologies if it's slightly off. But anyways, now this is our original graph of y is equal to fx, and we do in fact have to state the intercepts of this graph. So let's do that, and we make sure you always draw your graph before labeling your intercepts. This just makes it a lot easier. So this is just 4, and now we actually have to in order to draw an inverse of a function. An inverse of a function is basically the function reflected in the line y is equal to x. So let's draw a straight line here. and we can call this as, let's label this line as y is equal to x. So how are we going to reflect this graph so that we can find the inverse? Basically, pick any point you like, so we pick 2 points here, any 2 points on the graph, and so we just have to draw a straight horizontal line to the line y is equal to x, and then once we hit it, we go down, we just move it down. May not be perfect, but it's alright, it's just a sketch, right? So move it down until we reach the same point. Oh, I've made a mistake here. This shouldn't be so far extended. Okay, so now we can plot 2 new points here once they are reflected in the line y is equal to x, and then we can draw our inverse graph. So let's use blue for our inverse. Oh, okay, it slightly doesn't hit, but that's alright. You can just modify that. There you go. Oh, and make sure you also label the x-intercept for this graph, which is just 4. And that's it. This is your full inverse graph drawn. Always make sure you have the line y is equal to x labeled, and you should also label your graphs here, fx, and this is f inverse. Alright, that's it.